Welcome. Today I would like to show you a prototype of a machine learning service that we have just made available online and that is geared towards developers to work with machine learning assets in Bluemix and a set of services that we have available there for various types of analytics. Let's first take a brief look at the current situation in Bluemix. There is now the new analytic experience that you see here, where you can already see various services for analytics assembled together. So let's look at some of them. Let's start with the Spark service that you find here in the analytics link, and that allows you to create and interact in an experimental and iterative way with some data that you pull in from various sources and work out a certain transformation stream and basically analytic and modeling flow. So in essence, it allows a data scientist to work out machine learning assets and store them. Next, let's take a look at another service that is available in Bluemix, and this is the Predictive Analytics service, which is based on SPSS technology. This one provides mostly just an API to upload SPSS modeler streams and use it later on for scoring. And it has a very thin tooling layer that you can see here to support this upload and manage the uploaded models with a few operations. But it's basically SPSS specific, as you can see it here. And now let's take a dashDB, which is another of the analytic services in Bluemix, and specifically it's a built-in support for R analytics. When you open dashDB, you will see that you get both abilities to interactively design data science machine learning assets and to also use them through APIs and SQL. So here you can see how you can create R scripts, and there's the built-in ability to run RStudio. You can open it and interactively work and create R assets, scripts, test them, and just store them on disk. And then you will get APIs to run them through REST. Whatever you create there within database analytics, you get also some interactive tooling to manage the generated machine learning models that are stored in dashDB in some way, as you can see it here. But also this management model is now specific to dashDB. What can we do to become more generic and cross-service now and specifically support the developer to make his way? The following that you will see is meant to eventually land in something like this exchange area that already exists and currently is only used to exchange plain data. So now I would like to introduce to you the machine learning service that we have just made available online. It is currently in prototype state, but you can find it at the URL displayed on the screen. So when you go to this URL, you will be first confronted with a login screen, and this is just nothing else than your Bluemix ID. So just log in with your Bluemix credentials, and the first thing that you will get after that is a little setup screen where we will ask you to specify your Bluemix region, organization, and space where you would like to set this service up, from which you would like to use other services such as dashDB and SPSS. The next thing that we'll provide here is that you can select the dashDB instance that you would like to work with in this prototype. And in addition, we will create under the hood an SPSS Predictive Analytics service instance for you, and in the future you will also be able to select previously existing ones. In the next step, you can select some initial sample models that would be deployed out of the box for you, so you have something to start playing with initially. The setup can take a few minutes. When it's done, you will get this catalog screen that you can see here, and it already shows the just selected default models, 2 for dashDB and 2 for the SPSS service. So let's play with them. Let's take one of the SPSS models here and see what it provides to us. When you open it, you get a holistic view of the model. First, an overview with some description, as you can see it here, and in the metadata tab, you will get all the input and output parameters that you need to know and provide and consume when you want to use the model in your application. But you can also really try the model. Go to Score and then select one of the scoring options. So let's do real-time score, which means we provide the data on the fly. So if you don't have an idea what kind of data is needed for these inputs, you can get hints that are provided with the model, like you can see it here. After looking at them, we now have a good idea of what kind of data we could provide to try out the model. So let's just provide a few values on the fly, and let's see what recommendation we will get. So this model gives us a prescription recommendation for drugs based on some blood metrics that were observed. Alright, now we can see our scoring result, which is basically the drug recommendation given for this input data. All interactions with the model are recorded in the History tab. You can always review and get a holistic picture of what has been done with your model over time, so you can look what scoring was run with what data, what was the input, and what was the output, for instance. The ultimate goal of all of this for the developer is to really be able to consume the model in his application or solution. So let's look at the API tab. Here you find a fully functional Swagger UI specifically for this model. You can learn about the available REST endpoints, its parameters, and also try it out interactively. So for instance, here we try out a simple scoring run via the scoring endpoint, providing the input data, and see how the output data looks like in JSON. So now I know exactly how I can use it in my application. These REST endpoints are also providing really the holistic coverage for this model. So I could, for instance, also get a REST endpoint to get the hints for this model if I would like to consume that in my application, or to get the semantic description that is provided with this model just by using the according REST endpoint for that. So now let's go back to the catalog view and let's try out one of the other models. This time we take a dashDB model, one of the dashDB sample models. This one is for customer churn prediction, and we open it, we again get the same view, we get the description, semantic description, we get the input and output. In this case the input is very simple, it's just the duration of a customer contract. So let's just try it out immediately. We go to Score, real-time scoring in this case, and provide one of the inputs that we think might be right, and we see what the prediction will be. In this case 0 means no churn. And also here we have all the track record of the lifetime of this model in the History tab, where we can just always see what has been done with this model over time. And finally, let's look at the API. Also here exactly the same API, the same capabilities like with the SPSS based model that you have available. Now let's add some new models. We are now a developer, so we are not a data scientist, so we have not really all the skills to create them with tools like notebooks or even more fancy things and R and so on. So we need something that is simplified, is so-called auto modeling. And in fact, the machine learning service provides that in the Add Model option here. So when you open it, you give the model first a name. In our case, for this test here, I would like to create a model that predicts the gender of tweet authors for certain kinds of tweets, in this case for tweets about cars. My training data is in dashDB, so I'm selecting a dashDB in-database model now. You can now select which algorithm you would like to apply to train the data and where the data is in dashDB. So go to select the schema and then finally the table. In our case, we have a special table where I have put my training data beforehand for the tweets. This one is an observed learning, so there are a set of tweets where there's already annotated what gender the author of these tweets had. We can directly review the input data here, so we can now figure out what is actually the target property that we would like to train. So we select the target column. In this case, it's the author gender column. And we also need to select the primary key for this algorithm here of the source data. So we do that as well. And then we can just hit the create button. After a little while, the model is created and we can go back to the catalog view. we find our new model here under the name that we provided. And one thing we could, for instance, try out now is to try to get a little explanation of the model visually. And in fact, this is possible here with the Visualize button. Just click on that, and in this case, it's classification model. And when you visualize it, you will see, in fact, what is behind that is a decision tree that shows up here. Now we also document actually what our intention of this model was. So we just describe what we actually wanted to do with this model when we created it. In this case, you want to detect or predict gender of tweet authors. Now we briefly review the input and output in the metadata tab, and then immediately we try the model out in action. So we go to score and first try a real-time score. So we do have some idea how the model data looks like, because we provided also the training data just a minute ago. So we type in some input values here that are reasonable, and as you can see it here, also you can provide multiple records of input data just by adding them up, and then we can hit the score. Okay, so what we see as a result here, that for this made up input data we just have 2 times a male author that is predicted. Now let's try it with some real data. Go back to score, and this time we use batch scoring, and for this in database model the input of batch scoring is a table. So we select the schema and some test data that I prepared. Next we select, we can review first the input data again, and then we select the primary key that this algorithm requires, and also provide where the batch scoring should write its target data. And in this case, it's in a database model. Well, it's just a table, so we provide the table name that should be created, and the scoring results should be written. Then we hit the Score Now button, and after a little while, the score results are displayed on the screen. And once more, all what we have done is available in the track record here in the history. So we have done 2 scoring runs to the new model. We can again review what was the input and the output to these scoring runs. And we also have done a visualization at the beginning, and we can also review the visualization result again here out of this context. And it should go without saying that, of course, also for this new model that we just trained automatically, we will have all the APIs available in exactly the same way like for the sample models that we have seen beforehand. So this is the end of this little demonstration. I hope you will find it useful, especially when you try it out. So please go here again to the displayed URL and let us know your thoughts and feedback.